Okay, so today we are going to talk about ionic bond, why elements are reacting, what is the need of reacting. Okay, so we already learned the last group of elements, which is noble gases, that is 18th group of elements. They will not undergo any chemical reaction because they are stable. Reason, they have 8 electrons in their valence shell. That is called octet. So every element wanted to become like noble gases, to become stable by acquiring 8 electrons. So that is the reason for bonding, or we can say chemical reaction. So why do elements bond? You are going to write that there for getting completely filled valence shell. Or you can also write to get 8 electron, which is 8 electron, which is called octet. So to get 8 electrons in the valence shell. So there are 3 ways to get 8 electrons. Some elements will lose electron, some will gain electron, some will share electrons. So in ionic bond, we are going to talk about losing and gaining, because then only there will be positive and negative charge. So when atoms lose electron, they will form positive ions. They will form positive ions, and we will call them cations. Okay, an example, sodium, after losing one electron, it will form Na plus 1 ion. So we can call this as a cation because there is a positive charge. Okay. The same way, some elements, usually non-metals, will gain electrons. Okay. So when they gain electron, they will form negative ions. Negative ions. And the name for negative ions is anions. It's like A-N-A-I-O-N, anion. Say for example, if it is chlorine, it will gain one electron, and form Cl minus 1 ions. This will be an anion. So valence electrons are the only electrons which involves in bonding. Remember the valence shell. So when there is different energy levels like this, the outer shell is called valence shell, and the electrons in the outer shell, which is called valence electron. So only valence electrons are involved in bonding. They may lose or gain electrons. The number of electrons take part in bonding, or we can say the number of electrons lose or gain during a reaction or during bonding are called. So number of electron lose or gain are called oxidation state, or we can simply say charge of an atom. Or it is also called valency of an atom. Okay, if sodium is losing one electron, we can say the charge is +1 or the valency is 1. If magnesium is losing 2 electron, we can say charge is +2 and valency is 2. So you are going to label the charge for all elements in the periodic table. Okay, so we have, this is group 1. Group 1 always lose 1 electron, so their charge will be +1. Group 2 will lose 2 electron and the charge will be +2. Okay, say for example, we know that lithium is here and lithium will always show +1. And if it is sodium, they will show +1. And if it is magnesium or calcium or any element in this group, they will show +2. And group 13, that is group here, this one, they will have 3 electron in their valence shell, they will lose 3. So charge will be +3 or 3+. And group 14, they sometimes lose electron, sometimes gain electrons. So they may show plus or -4. And group 15, so this is group 14, and group 15, they will gain 3 electrons because they already have 5 electrons. They need only 3 more to complete their octet. Group 16 will be -2 because they have 6 electrons. They need only 2 to get 8. And group 17 will be what? -1. And group 18 will be 0 because they already have 8 electrons in their valence shell. So group 1 is +1, group 2 is +2, and all other groups are like this. And also remember about the staircase. I'm going to draw the staircase here. Okay. Everything above the stairs are non-metals. Everything below the stairs are metals. So metals will always lose electron and non-metals will always gain electron. And these ones, we didn't talk anything about the transition metals. Remember, transition metals are always little different. So transition metals will show multiple charges. So say for example, if it is iron, iron will show +2 and +3. Copper will show +1 and +2. So it is very difficult to memorize all this oxidation state. So you are responsible for only 3 elements in this. One is zinc, which is showing only one oxidation state, what is plus. Cadmium also showing +2, and there is silver is showing +1. So these 3 you have to memorize it. All other elements except these 3 are showing multiple charges, so you don't need to memorize it. We will learn a method to calculate their charges. They are showing multiple charges. And there are 2 other from this 14th group. We know that this is carbon, silicon, germanium, and the tin is there. Tin is also showing +2 and +4. And there is PB. Pb is also showing +2 and +4. So these also showing multiple charge. There are a couple of others. These will show multiple charges, but you don't need to study. We didn't include that for you. Okay, so everyone need to memorize the charges. Okay, so group 1 it is +1, group 2 +2, group 13 +3. And if the question is like this, what is the charge for fluorine? You are saying it is -1. And if it is for chlorine, -1. If it is oxygen, it is -2. And if it is nitrogen, it will be -3. Okay, so we need to use that later on in your lesson. Okay, now we'll go to the next page, which is page number 7 only. So now we are going to see how the atoms are reacting by losing or gaining electron. For that, we are using Lewis dot structure method. So Lewis dot, remember, we are representing the valence electron using dots. We learned that in couple of units back. Okay, magnesium, which is in group 2. So how many valence electron will be there? 2 valence electron. Just I'm gonna put 2 dots on magnesium. And lithium, which is in group 1. So how many valence electrons there? 1. Fluorine, which is in group 17, so there will be 7 electron in their valence shell. And bromine also in 17th group, which has 7 electron. Oxygen is in 16th group, which has 6 electron. Aluminum, which has how many? 3 electron, because that is in 13th group. So now we are going to use the same Lewis dot structure to show the bonded electrons, okay, to represent what? Ionic bonding. Okay, let's see. The first example we are going to see, it is a compound between lithium and bromine. Okay, so imagine we are heating lithium with the bromine. They will react and form a compound, lithium bromide. So lithium is in group 1, which has 1 valence electron, and bromine, which is in group 7, which has 7 valence electron. So both of them wanted to become stable by getting 8 electron. So lithium will become, after losing this electron, it will become like helium. So it will get a special stability. There is only 2 electrons in there, but still it will become stable. So lithium wanted to donate this electron and bromine needed 1 more. So lithium will give this electron to bromine. So what happened after that? Lithium lost its electron. It will become a positive charged ion. Okay, there is a positive charge in lithium. And bromine got 8 electrons now. It is also happy. And there is a negative charge in bromine. Okay, now they are like a family. And we know that whenever there is a positive charge and the negative charge, there is a Coulombic force of attraction that will hold them together. Okay, so that attractive force make them stay together like a single compound, and that attractive force is called ionic bond. Okay, let's try next one. Okay, here magnesium has this in group 2, so has 2 electron, and fluorine, which has 1, 2, 3, 4, 5, 6, 7 electron. So magnesium wanted to donate to get stability like neon. After donating 2, it will get 8 electron in their valence shell. So magnesium is donating 1 electron because fluorine needed only 1. Fluorine is stable now, but what about magnesium? It still need to donate 1. So it will extend the family by adding 1 more fluorine. Okay, so that fluorine also has 7 electron. It is added to this. It's donated to that. So in a result, magnesium lost 2 electrons, so that will become positively charged ion, and fluorine got 8 electron. There are 2 fluorine. One fluorine become 1 minus and other one also become 1 minus. So as a result, we can write there is 1 magnesium and 2 fluorine. That compound will be MgF2. Okay, now this is your turn to try the next one. Okay, everyone go ahead and pick aluminum. Aluminum, it will need a more space. Okay, aluminum which has 3 electrons, and oxygen has 6 electrons because it is in 16th group. Okay, aluminum wanted to donate 3, but oxygen needed only 1. Let's see how we can do it. So aluminum will give these 2 electrons to oxygen. So this oxygen is happy, but aluminum still need to donate 1 more. So we'll take another oxygen here. I'm gonna draw on this side. I don't have space. So this oxygen also needed 2, but this aluminum has only 1. It will give that electron to that oxygen. But this oxygen is not stable. It needs more electrons, so we are going to take 1 more aluminum, which has 1, 2, 3 electrons. So it donates 1 electron to oxygen, so that oxygen is also happy. Now the problem with this aluminum, which still need to donate 2 more. So we will do 1 more oxygen, which has 1, 2, 3, 4, 5, 6, and this aluminum donates 2 electrons. So in total we can say there are 2 aluminums and 3 oxygen. 1 aluminum lost 3 electron and 1 oxygen gained 2 electron. There are 2 aluminums, so total they lost 6, and there are 3 oxygen, 3 times minus 2, they gained minus 6. This number should always equal. One is donating total 6, one is gaining total 6. So when you add up all the negative and positive charge, it should be equal to what? 0. Plus 6 plus minus 6 equal to 0. So that is ionic bonding, and there is an easy way for writing the formula. We will learn that in a minute. Before we go there, let's see the size of ions after removing or gaining electrons. So remember the periodic trends: when we move down, size increases, move left to right, size decreases. So here we are going to see the size of the ions. So we know that when atom lose electron, it forms cations, which are the positively charged ions. So what happened to the size? Say for example, if sodium is losing electron, okay, it will become sodium plus ion. So it has 11 electrons earlier. Now it has only 10 electrons. So we can see in the case of sodium, There was 3 energy levels before. After losing electron, there is only 2 energy levels. Oh, there is more protons in the nucleus. So when atom lose electron, they will become smaller. So size decreases. So you have to write, easy way to remember, cations. Cats are smaller, so cation will be small. When atoms gain electron, they will form negatively charged ions. Say for example Cl, after gaining electron, there is an extra electron there. So as a result, the size of an ion increases. So you can say anions will be bigger than the atom. So if we compare atom and ion, this will be bigger. But when we compare atom and cation, the atom will be bigger. Okay, so this image will help you to understand. So all the red ones are cations and the gray ones are the parent atoms. So this is lithium and this is lithium plus ion. So the plus ion is smaller than the atom. So all cations are smaller than their atom. And when you look at the right side, all blue ions, which are anions, and the gray ions are atoms. So blue ions are, negative ions are bigger than their parent atom. Okay, let's go to the next page and do a couple of questions. Okay, one more time. A positive ion is called cation. So this is a cation. It is formed from an atom after losing electron. A negative ion is called anion. It is formed from an atom after gaining electron. Now the question is, so this will be, cation will be smaller and anions will be bigger. So who is smaller among the pairs? Circle the correct answer. Okay, we are going to find the smaller one. So anions will be bigger, so the atom will be smaller. If it is a negative charge, that will be bigger. There is a positive charge, that is cation, that will be smaller. Na and Na plus, positive will be smaller. S and S2 minus, negative will be bigger, so this will be smaller. Okay, now answer the next questions. Who is larger? So we know that positives are smaller, so the larger will be the atom. We know that negatives are bigger, that is the biggest ion. So negatives are bigger, that is the biggest one. Positives are smaller, so the atom will be the biggest. Okay, so now this is the last one we are learning today. Ionic names and formulas. So we are going to learn formulas today and names tomorrow. So for writing the formula for binary means containing 2 atoms, okay, 2 atoms. Formula, write down the charges of ions and then we are doing crisscross to find the number of atoms. Forget about the charges, okay? Let's do an example. So you are going to writing the charges of ions. So here sodium, the charge is group 1, so plus 1. And nitrogen, it is group 15, 5 electron gaining 3 minus 3. Okay, that is the first step. You are going to write the charges. We already wrote the charges. Then now we are using a crisscross method. So for crisscross method, I'm gonna bring this number to this one and this number to this, and you need to completely neglect or forget the charges, forget the sign of the charges. Okay, so I'm gonna bring the number 3 here and the number 1 here. That is called crisscross method. So sodium needed how many atoms based on the charge of the next one? So that is 3. And nitrogen need only 1. So the formula is Na3N. Is that easy? Okay, try next one. Gallium is in group 13, thus the charge is plus 3. F is minus 1. So we are doing the crisscross. Bring the 1 here. We don't need the charges, remember. And the 3 is here. So the formula will be how many Ga we needed? 1. And if it is 1, you don't need to write it. And fluorine, it is 3. So write 3 there. So formula is GaF3. And for some questions like this, okay, you have calcium. Calcium is in group 2, so it is plus 2. Oxygen is minus 2. Okay, so we do the same thing. We'll do the crisscrossing, bring that down. So you will get Ca2O2. But this is not correct, because whenever there is number which are reducible, you have to reduce that number. 2 and 2 are reducible. So the correct formula, I'm going to divide 2 with 2. So you will get CaO. Next one, Ge and S. Germanium, which is has a charge of carbon. Germanium has a charge of plus 4 because it is in carbon, silicon, germanium. Yeah, it's in group 4. And sulfur, which has a charge of minus 2. Okay, we'll do the crisscrossing method. Bring this number here and bring this one here. So you will get Ge2S4. But we have to check whether these numbers are reducible or not. Yes, they are. So I'm going to divide both this number with 2. So 2 by 2 is 1. 4 by 2 is 2. So the formula will be 1:2. That is GeS2. Okay. Next one, aluminum. Aluminum is this one, charge is plus 3, nitrogen minus 3. We'll do the crisscrossing, then you will get Al3N3. But these two numbers are reducible, so reduce that. You can divide that with the 3, so the simplest formula will be ALN. Okay, that's it for today.